Okay, welcome to this video. So we're going to be doing a review for your test over polynomials. So I'm going to go through basically one of each type of the graph or two, starting with quadratics and then going through x3s and x4s, x5s, and then on another video we'll also do rationals. So this one will probably just cover quadratics. So if you are struggling with quadratics or remembering how to do quadratics, that's what this video will be over. So I will try to go real slow and ask you questions as I go along. I would strongly suggest to you that you pause the video at times when I ask questions. Think about what the question is and see if you know the answer. So try to go ahead and work something out possibly, or at least think about it, and then go ahead and watch the video and see if in fact you know it's right. Because guys, when you just watch me do it, some of you guys are just watching it and you're not even listening right now, so you're not even hearing this. But if you just watch me do it, you're never going to fully know if you know how to do it. Okay? It's like anything else you do. Even if it's playing sports, you can watch somebody play all day long and think, oh, I can do just as good as them. But until you actually get out there on the court, you're not going to know how well you are. So please pause the video and think ahead at the questions that I ask. Okay, so we're going to go ahead and get started. So this first one, and I forgot to put some of the questions on here, but the first one would be, what is the degree of this polynomial? Okay, so the answer to that question, your degree, in this case, is that this is a degree 2. Okay, degree 2. And so if it is a degree 2, what will be the end behaviors of this graph? Okay, so the answers would be, in terms of end behaviors, as x goes to a negative infinity, y is going to go to a positive infinity. And as x goes to a positive infinity, y will go to a positive infinity also. The other thing that I would say is to just do a quick sketch over to the side of what possibly it might look like. You don't have to put it on the graph itself, but just do a sketch. So just out to the side here, just do a quick sketch. What will this graph look like? And hopefully you thought it's going to look like a parabola. And you do need to know what these are called. That one has a special name, a parabola. Okay, so my next question is to state the number and the type of possible solutions, not what solutions it has, but what kind of solutions might we get. Now, what I like to do, what I showed you on an earlier video, is to set up a little table. And we always put real and imaginary. Now, I want to back up because I'm not sure if some of you know what we mean by real solutions. Okay? So when I talk about real solutions, guys, I'm talking about real numbers. Well, the real numbers, guys, are all of your whole numbers. They are all of your fractions. And they are your decimals. And those decimals are whether they are terminating, like 0.5, or whether they're non-terminating or repeating, which might be like 1/3 or 0.3 repeating, or they could be something like your square roots, cube roots, or whatever that are not perfect. So that would be like the square root of 2 or the square root of 5 or maybe the cube root of 2. So all of those are real solutions. Now when we're graphing, what we're looking for, okay, that's going to help us graph is those whole numbers, possibly a fraction, like 1/2, something like that. But what we don't want to get, preferably, would be just the decimals and the terminating. But we could, if we had to run the quadratic, you could get those, okay? But you're going to get these from factoring or by synthetic, okay? These you're going to get by the quadratic formula, okay? So that's what we're talking about with real numbers. Then, of course, that whole set of numbers, then you've got the other set, which is your imaginaries numbers. But when we say what real solutions, that's what we're talking about again. But really what we're looking for, hopefully, is the whole numbers. But since it is a degree 2, we can have 2 real solutions, no imaginaries, or we can have just 2 imaginaries and no real, okay? And again, the key is to remember those imaginaries come in pairs, so we've either got 0 or 2. I could not have 1 and 1. Okay. Next up is to find the vertex for my parabola. Now, hopefully you guys all remember this. And to find my parabola, again, your x is a negative b over 2a. So in this case, it would be the opposite of a negative 2 over 2 times 1, which is 2 over 2, which is 1. That's my x value, 1. And then I'm going to go in, and this is where we go back to our function notation, guys, and we put in that 1. I kind of didn't leave enough room here. So we put in the 1. So f of 1 would, okay, here's my equation. What would be f of 1? And that would be 1 squared minus 2 times 1 minus 35. And that is going to give me a big number, it looks like. I'm seeing it be, oh, I can't math in my head right now, negative 36. Does that sound right? Okay, so negative 36 would be my vertex. So 1, negative 36. That's just a really weird number. Okay, I don't know why I wrote something that big as a problem. Y-intercept, again, is your what number? Okay, so did you get 0, negative 35? So that does sound logical then, that my if my vertex is at, so I'm going to go ahead, and since I've got some really weird numbers here, I'm going to go by 5s, okay? So 5, 10, 15, 20, 25, 30, 35. So there's my 35, okay? Negative, so we'll do that. I'll go green. So I have 0, 35. There, whoops, sorry. That always does that. I don't know why. So if I need to pick up my marker, I got to pick it up, or tap it. 0, negative 35. And my vertex was 1, negative 36. So because I went by 5s, it's just barely below. Okay, there we go. Remember, how would I know one more point? Okay, hopefully you said it's the reflection. So there it is. Now we're going to find our x-intercepts. So I look at my equation. I only have really 2 options here. I have 3, but 2. One would be to factor, okay? One would be to run the quadratic formula. And the other, the third, would be to do synthetic division on your factors of a negative 35. That's probably not the method you would like to do, but it is an option. So let's just look at it. Will this factor? So what I'm going to ask myself, is there factors of a negative 35 that will give me a negative 2? And it will factor. x minus 7, and x plus 5. So I then take each of my factors and set it equal to 0. So I get x equals 7, x equals a negative 5. And again, we're supposed to be graphing these. So now I'm going to go to 7. And these I'm actually going by ones across here. If you noticed how I did that earlier, these are ones. 5's down, 1's across. So it'll look a little distorted, but that's okay. So I'm going to go to 7, 1, 2, 3, 4, 5, 6, 7. Because I already started on the down here when I did the 1, like I said, a little bit distorted. And then a negative 5. 1, 2, 3, 4, 5. Okay, so remember, you don't have to make your x and your y axis be the same. So anyway, we're going to sketch that in. Again, it will be slightly distorted, but there you go. Okay, if you'll remember, normally we would have also typed in our axis of symmetry on there, but that should look right, because if this is at 1 here, so this should be 6 over, and this should be 6 over. Okay. Okay. So that is, again, a review of your quadratic. Again, we've tested over that. We did a little bit of a review on the notes and so forth, but we really haven't graphed any per se in class, but hopefully we did the inverses. So you graphed part of them. We did graph a few at the beginning, but okay, let's just go on to another one real quick. So this one looks a little bit different because it is not in standard form. It is in vertex form. And guys, remember, vertex form is y equals a x minus h squared plus k. So we can look at it in terms of a translation versus needing to multiply it all the way out. Okay, so first off, our vertex in this case, so I'm not asking you for everything because we just answered a lot of them up above, but what would be the vertex for this equation? Okay, and hopefully you said 2, 0. 2, because again, there is a minus in this problem, so my 2, and then there's no number here added, so that's a plus 0. So my vertex is 2, 0. I can go ahead and come over here to my graph and put that on there. My y-intercept, what is it going to be? Now that's, in this case, that's going to require a little bit of work. So I'll give you a minute to see if you can figure out what your y-intercept is. Okay, so it's where x is 0. So again, this is a function notation where x is 0, 0 minus 2 squared, and that's going to give me 4. Okay, so 0, negative 4. 0, 4, sorry, my bad. Did I miss something there? 0, I feel like I'm missing something. Oh, y-intercept. I don't know what I'm thinking. 1, 2, 3. Sorry, my brain froze there for a second. I don't know what I was thinking. Okay. Again, we've got also our reflection point. So where would that be? Okay. If it's 2 over there, it's 2 over here. Okay. So the next thing is our x-intercept. Okay. So that's where we're going to let y be 0, and we set our factor equal to 0. Now, this is a multiple root, right? It has 2. X equals 2, multiplicity of 2. And then the question is, how many of you said or are thinking, why did she just do that? Because did I really need to show that work? Okay, hopefully you ask yourself that. Because look at your graph, guys, you already have your y-intercept or your x-intercept, right? And it does fit as a multiplicity of 2, because remember, that means it's going to touch and bounce. And so we see that from our graph because we're going to come down, touch, and bounce up. Okay? So that is your quadratics. So again, that's where we're going to stop on this video. But you need to be sure that you can graph a quadratic and answer any questions that I ask you over a quadratic.